Welcome. Today we discuss few problems on vector. Today is part 2 of that chapter. Let us take the first problem as let A 2, 3, 4 and B 4, 2, 5, 2, 3, 3. Oh, sorry. A 2, 3, 3 and B 4, 2, 5 are 2 points. The angle which AB makes with Z axis. Options: cos inverse 1/3 pi by 4, cos inverse 2/3 and cos inverse and pi by 3. Then problem is very straightforward. A and B are two given points. We have to find AB makes the angle which AB makes with Z axis. So position vector of AB vector it is position vector of A B minus position vector of A. Position vector of B minus position vector of A is equal to 4i minus 2i. This is 4i. 4 minus 2 into I plus 2 minus 3 into j, difference of j components, y components, plus 5 minus 3 into k, which is equal to 2i minus j plus 2k. So actually this is AB vector. Its magnitude is equal to root over of 2 square plus minus 1 square plus 2 square. 4, 8, 9 is equal to root 9 is equal to 3. তাহলে unit vector along AB is equal to 1/3 into 2i minus j plus 2k. So its z component is 2/3. Z component of unit vector along AB is 2 divided by 3. Therefore, its angle which AB makes with Z axis is cos inverse 2/3. So this one is correct option. Now, take the second problem. Let AB, CD, EF be a regular hexagon and x and y are the vectors along AB and BC, then vector along CD is options y minus x, x minus y, x minus 2y, 2x minus y. Let us draw the figure first. ABCDEF is the regular hexagon, means all sides are same, all angles, all included angles are same. So x and y are the vectors along AB. So this is x vector, and along BC is y vector. We have to calculate the vector along CD. This vector is what? Options are there. Now, if I join C to D from property of regular hexagon, length of AD is just double of BC or FE. So AD vector, this is parallel to that. So it is 2 times y vector. 2 times means because its magnitude is just twice of that. EF, FE, it is also y. But anyway, let us join A to C. AC vector is equal to AB vector plus BC vector. AB vector is x vector plus y vector. Once again, AC vector plus A to C plus C to D is equal to A to D. A to C, then C to D, it is A to D. So that is AC vector. Just now we obtain x plus y vector plus CD vector. We have to know what is value of CD vector is equal to AD vector. AD vector is 2y. Therefore, CD vector changing side, 2y minus this minus that, 2y vector minus y vector minus x vector is equal to y minus x. So y minus x, first option is correct. Next. The angle between the vectors I plus 3j plus 10k and I plus 3j minus 10 minus k, only k, minus k is how much? Angle between this vector and that vector. So options are there: 45 degree, 60 degree, 30 degree, and 90 degree. We have to find the angle between two given vectors. Suppose this vector is A, this vector is B. Angle can be obtained from the property of dot product. A dot B, we know that A dot B is equal to magnitude A, magnitude B into cos theta. Component, the vector A and B, their components are given. So from this component, A dot B can be obtained, magnitude A can be obtained, magnitude B can be obtained. So only thing, theta, cos theta left, so cos theta can be obtained from the other two. So A dot B here, A dot B is equal to, it is corresponding components, that is 1 into 1 is 1, 3 into 3 is 9, plus 10 into minus 1 minus 10 is equal to 0. A dot B is equal to 0. Magnitude A is equal to root over of 1 square plus 3 square plus 10 square. That is 110. Anyway, it is positive. It is non-zero quantity. Magnitude B, it is equal to root over of 1 plus 3 square plus minus 1 whole square. It is 9, 10, 11. This is also non-zero quantity. So putting it there, 0 is equal to magnitude A means root 110 into root over 11 into cos theta. So cos theta is equal to this by that, 0. Therefore theta is equal to 90 degrees. So this one is correct. Next one. One vector A makes angles. A vector A makes angles pi by 4, pi by 3, and theta with axis. Means it makes an angle pi by 4 with x-axis, pi by 3 with y-axis, and theta with z-axis. And if magnitude A is equal to 4 and A makes an acute angle, with z-axis, then A vector is options. Two into root 2i plus 2i plus 2k, 2 root 2i minus 2k. Third option, root 2i plus minus 2 root 2 j minus k, and fourth option is 2 root 2i plus 2j minus k. So actually, about a vector A, the informations are: number one, it makes pi by 4 with x-axis, pi by 3 with y-axis, and theta with z-axis. Magnitude A also given, which is 4, and also given that A makes an acute angle with z-axis. Then vector A is, so its vector A, its direction cosine, actually cos of pi by 4, direction cosine, cos pi by 4, cos pi by 3, and cos theta. So from this information, theta can be obtained very easily, because cos square pi by 4 plus cos square pi by 3 plus cos square theta is equal to 1. So that 1 by 2 plus, it is half, cos pi by 3 is half square, plus cos square theta 1, only one unknown. So cos square theta 1 minus half, uh, 1 minus half, that is half minus 1 by 4. So it is equal to 1 by 4. Just 1 minute. Cos square theta is 1 by 4. This is 3 by 4, 1 by 4. Okay. Then cos theta can be solved plus minus 1 by 2. But given that cos theta is equal to either plus half or minus half, but given that the vector A makes an acute angle with z axis, it is it is the angle which the vector makes with z axis. So it cannot be negative, because it makes an angle, acute angle. For that purpose, cos theta is equal to half. That is, theta is equal to pi by 3. Therefore, now at this level, we find three angles which A makes with the axis. Therefore, cos theta will be equal to magnitude A into cos pi by 4 x component I plus cos pi by 3 j plus cos theta k. That is, it is equal to 4 into cos pi by 4 means 1 by root 2i plus half I plus half k. So component is 2 root 2i plus, not component, vector A is 2i j, this is j, plus 2k. First one is correct option. Next one. Projection of A 4i minus j plus 3k on b I plus 2j plus this one is ineligible. Six k. Then we have to find the projection of the vector A, this vector, on vector B. B vector is I plus 2j plus 6k. The options: 18 by root 40, 41 by root 20, 20 by root 41, and 15 by root 41. We know that for projection of any vector A on vector B is simply A dot B by magnitude B, because you see this vector is B vector, say this vector is A, this is B. So projection of this means this one, only that part. That is, if it is A and angle between A and B is theta, then it is A magnitude A cos theta. And A dot B is equal to magnitude A magnitude B into cos theta. We want, actually it is A cos theta, magnitude A cos theta means it is A dot B by magnitude B. Therefore, simply we write projection of A on B is A dot B by magnitude B. Now A dot B is equal to this dot product with that. So 4 into 1, 4, minus 1 into 2, minus 2, plus 3 into 6, 18, divided by magnitude B, that is root over of 1 square plus 2 square plus 6 square is equal to 20 divided by 36, 40, 41, root 41. So that this is correct option. Now, next problem. If the vectors A, B, C are such that A plus B plus C, sum of these three vectors is equal to 0, 0 vector, and magnitude A is equal to 3, magnitude B is equal to 5, and magnitude C is equal to 7. Then angle between A and B. Angle between A and B is options: pi by 3, cos inverse 1 by 3, cos inverse 2/5 and pi/6. So from the given information, we have to find the angle between A and B. So if I can somehow find A dot B, A dot B is equal to magnitude A, magnitude B, and cos theta. If I know that A can be given, magnitude B given, so now from this relation we can find theta, cos theta, that is theta. And for that purpose, we have A plus B is equal to minus C. So A plus B dot A plus B is equal to minus C dot minus C. That is, from there, A plus B dot A plus B means magnitude A whole square plus magnitude B whole square, all vectors, plus 2 A dot B is equal to C dot C means magnitude C whole square. That is, A dot B means magnitude, okay, this is A square, magnitude A square means 9 plus magnitude B is 25 plus 2AB is equal to magnitude C whole square, that is 49. That is 2A dot B, 2A dot, this is A dot B, is equal to 49 minus 34. 49 minus 34. It is equal to, it is 5, 1. So again 2 into A dot B. A dot B means magnitude A, magnitude B into cos theta is equal to 15. 2 magnitude A means 3, magnitude B means 5, cos theta is equal to 15. That is, cos theta is equal to half. 15 cancel, cos theta is equal to half. Therefore, theta is equal to pi/3. So, first option is correct. If the angle between A, I minus 3j plus 2k and B, x square I plus 2xj plus 4k is obtuse, means angle between A and B is obtuse, it is given. Then range of x, this scalar quantity x is unknown here, range of x is what? So options, -1 less than x less than 2, 2 less than x less than 4, 1 less than x less than 2, and 0 less than x less than 4. Acha base, okay. Given that angle between A and B is obtuse, that is, cos theta is negative. Now, from this relation, A dot B is equal to x square into 1, that is x square, 2 into minus 3, that is minus 3x, and 4 into 2, that is 8. A dot B is equal to that. Again, A dot B is equal to magnitude A, magnitude B into cos theta. Value of magnitude A and value of magnitude B must be positive. So this is positive, but cos theta is negative. Therefore, this is negative. So A dot B must be negative. A dot B is x square minus 6x plus 8 is negative. That is, factorizing this, x minus 2 into x minus 4 is negative. So x is such a quantity that this into that is negative. This point is say 2, this point is 4. If x lies after 4, this is positive, this is positive. It cannot be negative. If x lies before 2 here, then x minus 2 is negative, x minus 4 also negative. Their product is positive, so it cannot lie there, it cannot lie there. If x lies between 2 and 4, then 2 after 2 and before 4, this is positive, this is negative. So we must have 2 less than x less than 4. So that option is correct. Next problem is let A I plus 2j minus k, B vector is equal to 2I plus j plus k. Then component of A, its component perpendicular to B. How much? So options, it is half j minus k, 3 by 2 j minus k, 1/3 I minus j plus k, and 1/3 I plus k. These are the options. So let us see the problem. A and B, two vectors are given. We have to find the component of A, its component perpendicular to B. Perpendicular to B. So we know that component perpendicular to B is equal to A minus A dot B into B vector divided by magnitude B. This is actually component of A perpendicular to B, and vector a component of A along B, it is equal to A dot B, this one, only this one, by magnitude B. আচ্ছা বেশ ঠিক আছে, okay. Then we have to find one by one. So component perpendicular to B is that one, is equal to A vector. A vector is simply I plus 2j minus k minus A dot B, that is dot product of these two, So 2 plus 2 minus 1 divided by magnitude b is root over 2 square plus 1 square plus 1 square. Into b vector. B vector is nothing but that 2i plus j plus k. It is equal to I plus 2j minus k minus 3 by, this is 4, 5, 6, root 6. 4, 5, 6, root 6 into this vector. This is equal to 2i plus j plus k. I think, oh sorry, this is this one whole square. This is actually this. So it is not root over. So this is 6 is equal to I plus 2j minus k minus half of that. That half of that is I plus half j plus half k. I cancels 2i minus 2j minus half j, 3 by 2j minus k minus half k minus 3 by 2 k. So that 3 by 2 into j minus k. So that one is correct option. Yes, let us stop today. Next day we will discuss few more problems on that chapter. Thank you.